The topic is STL, that is Standard Template Library. So before talking about this, let us understand what is the need of STL, why we need, right? So let us understand this, then I will come to STL. See, we have written so many programs, we have declared simple variables, we have defined our classes and created objects for those classes, we wrote the functions, parameters were fast. So all the programs that we did were simple programs that were for learning the features of C++ or the syntax of C++. Then really when you develop some application, then you have to deal with the data. So what will be the size of the data? That is a very important thing. So will your program or application will be dealing with one or two values or the list of values or the collection of values? So yes, program will be dealing with collection of values, not just one or two values, right? So then where do you store the collection of values? So for storing the collection of values, we need data structures. This is one of the important topic in computer sciences. This is a subject, so there are various type of data structures. In academics, engineering students study about this subject and try to write the programs by themselves for implementing data structure. So what is data structure? Data structure is a collection of data and the arrangement of that data for its efficient utilization. So depending on your utilization, you can arrange the data so that it can be utilized efficiently. Efficiency in terms of time and space. So we want the data to be stored and retrieved easily and also occupy less space. So when you have collection of data, then where do you store data structure? So what is the data structure available in C++? Let us first take the example of data. What data I want to deal with? So let us say I want to deal with the marks of student in particular subject. So I have marks of 10 students. And upon that I want to find who is maximum, who is minimum and all, so many operations I want to perform. I want to sort them and I want to find average. So there is a collection of data. So let us take an example of 10 student marks. So where do you keep 10 student marks? We keep them in an array. Yes, we create an array like this. Now in this I can store marks of all the students like 85, 72, 39, 40, 54, 76, 95, 98, 49, 64. I have kept the marks of 10 students here. So this is an array. So the built-in data structure available in C++ or mostly in any language is an array. Array is a collection of similar type of elements. Let us say these are integers. So I have to declare an array like this, integer a of size 10. Or else I can create an array like this also with same name I am using here, new int of size 10. So you know the difference that this array will be created inside stack and this array will be created inside heap, that is dynamic allocation. This will be created in heap. Wherever it may be created, I'll be getting an array of size 10 and I can store some 10 numbers. Now what I can do with these numbers? I can display all the numbers, find the sum of all the numbers, average of all the numbers, maximum number, find out this one and find out how many people got less than 50, how many people got greater than 80, like that. Lot of things you can do on this one. So when you have some collection of data, you can do a lot of analytical work, a lot of operations you can perform. So we understood that. I have taken an example of only numbers. Okay, you take any application, like suppose a reminder app in your mobile phone. It will have the list of entries with the date and the time and the message that you want and whether you want to repeat or not. So that is one entry. Like that there are list of entries. So it's an array of entries. So whenever you open reminder app, it has to load all those entries from the memory and keep it in an array. Let us take an example of a music player in your mobile phone. Just you open the music player, it will find out all the songs available on your phone and it will show the names of all those songs. So it has to bring it into an array and it has to show it. Like this, I can give you many examples where array is used for storing the collection of values. So I am explaining, so I have taken just integers, numbers. Now, let us learn more on this one. So what more I can do? Can I replace any number? This 40, no, this has to be 45. Yes, I can replace. Now, can I insert some number in this one? I want 77 to be inserted. Where? At the end or somewhere in between. There is no space. There is no space. That's it. So when you have an array, then whenever you create, you must be sure what is the size of an array you want. So once created, the array size cannot be changed. It cannot be increased or it cannot be decreased. So that is the problem with the array. So the arrays are available in C++ by default, but the problem is that their size is fixed. So initially only you should know the size and you should take a bigger size array. So you should have taken bigger size. If you are expecting more numbers, you should have taken bigger size. Okay, let us say it is having bigger size. Let us having bigger size. So suppose I have taken size 100, but I am storing only 10 numbers. So the problem is that the probability of utilizing an array with exact space is less. Either you may fall insufficient space in an array, or you may face the problem that a lot of space is wasted. So this is a common problem found in the built-in data structure of C++. We want to add more values, we want to delete some values. These type of operations are common on the data structure. So in this, the problem is space. Problem is space. Let us see if I wanted to insert 77 here, then what I should do? Move all the elements there and insert 77. If I want to delete 45 and move all those elements here. So for deletion and insertion, the data movement is required here. Now let us see next. So for that, I'll make some changes. Now let us take a situation that I expected that not more than 10 numbers. In my program, I have created array of size 10. And I have given the program to you. You are a client, you are a user, and you are using and you have entered more than 10 numbers. Then how my program can manage? My program will crash and you will complain me that I cannot store more than 10 numbers in the program. When the program is running, when I enter numbers, after 10 numbers it's crashing. Then I should make my program little intelligent that even if you exceed, then I should have bigger size array. How it is possible? This array cannot be changed. So one logic I will show you how we can increase the size of an array. We cannot increase the same size, but we can create a new size array with bigger size, okay? Then we can copy all these elements, 85, 72 and 39, 45 and so on. All these elements, copy all these elements here. And this was A, right? So let us say A is a pointer, it's pointing here. But now we can make it point on this one. So this is possible if you are creating it dynamically. So initially if you have created an array of size 10, then later you can say A assign new integer array of size 20. So a larger array will be created and the same A will be pointing there, and you can delete this array. So I gave you an idea that how we can increase the size of an array. So if you want, you can do this one. So this is the common logic used by programming. So that's it. I have discussed what is data structure, what is the need that you have to store the collection of values, then what is the available data structure, array, what is the problem, size, how you can solve it, you can create larger array and transfer all the elements. So it is just like, suppose I am conducting class, there are some 10 students, so shall I take a big hall and conduct a class? No, I can start in a small room. Then if the class is filled and the more students are there who are waiting outside, then I should ask these people to let us go to a bigger room. They can take a bigger room. And if still that is also filled, then I can go to even shift to more bigger room, or I can take a seminar hall or a conference hall for that one, where some 100, 200, 500 students can sit there. So that's what the idea is. Now if the students are gone, next day the strength is less and less, so I can come back to the smaller size rooms. So that same mechanism we want here, because the room size cannot be grown, it cannot be increased, we cannot push the walls and increase the size. So same way, array size cannot be grown. So this is one logic followed by the programmers. So that's it. So I'll continue more about the data structure in the next video.